It's January 2026. With $200 per month, you can have an AI that can write code better than 80% of software engineers. You can have an AI that can generate flyers or images as good as a marketing agency. You with $200 a month, you can have an AI that can do research as good as 80% of the analysts out there. So the question is, what's really stopping us from achieving AGI? Now you might be thinking the answer lies in NVIDIA chips or maybe better data. Well, the reality is the answer is electrons, energy. And I'll tell you why. Right now, we are building data centers that consume power faster than the grid can generate it. Training a single massive AI model already uses as much electricity as 100 US homes use in a year. As we scale up to AGI, that demand is going to vertical. It's going to surge a lot. We are going to require better energy. So, first of all, let's understand what's wrong with the way energy is right now. First, let's look at the renewable sources, the solar and wind. So when we look at solar and wind, they are great. They do not cause global warming, they do not affect climate change, they are clean. But the problem is that they are not reliable. The sun does not shines all the time. The wind does not blow all the time. So the issue is reliability. You need massive batteries if you want to use these for data centers that are going to power the AGI. And that just doesn't work on scale. It's very expensive to have batteries that can store energies which are coming from these sources. Next, we have coal and gas. Believe it or not, going forward for the short term, this is what's uh, this is the source which is going to be used, and it's bad. Well, because we
It's
are
not my
accelerating.
internet, right?
No, it's not your internet. It's
Okay.
frozen.
Sorry, can you
Like,
hear me now?
yeah. See, it's not reliable. You're just talking about.
Yeah. Indian internet is also not
I think
reliable,
his
but
one,
fusion reactor went off. I'm sorry.
yeah.
okay, can you hear me now?
One thing I was thinking about.
Hello, can you hear me now?
Our
Recording in
grids.
progress.
Can you hear me now?
Yeah.
Yes.
So sorry about that. No clue what's going on. Just give me a minute.
That was perfect. The next note is because you were talking about reliability, and we know that it was not reliable.
Okay. So let's have a quick recap. Did you hear till the issues with solar and wind that it's not scalable? Um,
Yes.
yeah, right. So the issue is massive batteries. You need massive batteries if you want to use solar and wind. So we'll continue with the next source of energy, which is fossil fuels. And believe it or not, in the short term, this is what we are going to rely on, and this is really bad because although we are getting better intelligence, but we are harming environment at the cost of it. So that is the issue with coal and gas. Also, not to mention it's finite. So, anyways, I don't want to get into it because I think this is pretty obvious. Next candidate is nuclear fission. The problem with fission is two. First of all, we have the issue of nuclear waste. And secondly, to build a nuclear power plant, you need at least 15 years. You can build a data center in maybe 2 years, but you need 15 years or more to get all those regulatory approvals to build a fission plant. So that is the issue. So what's the solution then? The solution is nuclear fusion. Why? First of all, it works on a very good fuel. which is available in abundance, which is water. The fuel for fusion is the isotopes of hydrogen, which are found in water, which we have a lot in abundance. So there is no limit on the fuel. It's very clean, no issues like coal and gas here. It's very reliable as well. It's very clean. You do not get climate change issues or global warming issues with this, or emission issues with this. This is very clean. This is also very safe. It either works and gives you energy, or it just shuts off. There is no possibility of events like Chernobyl happening with fusion. So fusion is a lot better in every sense. So when we look at fusion, there are essentially 40 companies in the space right now to build the first commercial plant. The frontrunner is called Helion Energy, and this is why Helion works. So first, to understand Helion, we need to understand how traditional nuclear fusion companies work, the other 40 work, so that we can understand how Helion works exactly and how is their technology better than the one which the other 40s are using. Now, and one thing I missed, the reason why I call Helion Energy frontrunner is because it has a contract with Microsoft, which says that they will deliver by 2028. It is chaired by none other than Sam Altman. Sam Altman has invested $375 million into it. So yeah, the reason why it's number one is because it's promising nuclear fusion by 2028. So let's understand how the other companies work and what the USP of Helion Energy is. So when we look at regular companies, what they do is they will use fusion to generate your energy. Then they pass it through a heat exchanger. They generate heat. It's passed through turbines. It passes through generators, and finally it we get electricity. So essentially, they are using fusion with the same 19th century physics, and it is very inefficient. The whole problem is inefficiency. You almost lose um, just get 60% of the energy of all the total energy exchange that is happening. So like the loss is of 40%, which is very, very high. Helion understood that you just cannot use this if you want to commercialize nuclear fusion. So let me show you a visualization of how their how their technology works. All right. So here's a visualization of their technology. So this is stage one, where you basically first generate plasma rings. Then they use magnets to accelerate these plasma rings. So it collides, forming a blob. And this, as you can see, once the fusion happens, the core compresses and then generates a lot of energy. The thing is that when this core is expanding, those magnetic fields which are there, they collide with each other, and because of this, direct energy is generated. So they are not generating heat or anything. They are just using direct energy conversion for this, which makes them very efficient. Their machines are smaller, their machines are cheaper, and they are infinitely simple to build. So this is why Helion is the state of the art when it comes to nuclear fusion, and this is why they are promising 2028. The only issue being that this is a new form of physics. Nobody has done this before, so it's a bet which is worth billions of dollars. Now they have performed fine till now, but the hand will be called in 2028 to 2028. So either we'll be switching on the world's first commercial nuclear fusion reactor, or we are going to experience a winter. AGI will become fiction. There is no way to achieve it without scaling energy. Uh, and not to mention all these alt ideas regarding nuclear fusion will fail as well. And we would have to stick to that uh, basic boring tech of nuclear fission, which is although boring and inefficient but reliable. And maybe someday when that works, maybe sometime in 2040 or something, maybe we can then talk about AGI. So let's hope that 2026 goes well and 2028 is even better.